Okay, so we're going to do all of these 20 through 23 for our notes. So it says that we're supposed to find the exact answer in radians over this interval from 0 to 2 pi. 0 is included, 2 pi is not included. So all of the answers need to be in radians instead of degrees. To solve a problem like number 20, this means that the cosine of theta is getting squared. So to get cosine of theta by itself, I'm going to have to take the square root. So I'm going to take the square root of both sides. When I take the square root of cosine squared, I'm going to get cosine theta. What happens though if I take the square root in an equation? What do I have to put over here? Plus or minus 1. So now we have to think, what does cosine mean? Well, we know SOHCAHTOA. And you need to know that the O is Y, the H is R, A is X. H is R, O is Y, A is X. So those go alphabetically as far as the A and the O. The A is the X value, the O is the Y value. Here's why, because if I have a triangle and here's my angle, that's an opposite, but it's also a Y value. This would be an adjacent, but it's also an X value. This is the hypotenuse, but it would also be the radius if I had a circle going around it. So that's the reason why they work that way. So cosine theta has to be plus or minus 1. Now think about this, guys. Cosine, like I said, that's going to be X over R. If X is 1 and R is 1, do we have any triangles over there on the board where X is 1 and R is 1? The radius is across from 90. Do we have any triangles like that over there? In fact, it would be impossible to have that. So what that means is that it has to instead be some angle that's on the unit circle. It has to be one of these, like 0, 90, 180, 270, also known as 0, pi over 2, pi, 3 pi over 2. So right here, I'm going to think of the points. This point is over 1 in the x direction, up and down 0. This point is over 0 in the x direction, up 1. This point is over negative 1 and up and down 0. And this point is over 0 and down 1. All right, so now the question is, where is x either positive 1 or negative 1? So look at these. Here's one place, 2 place, 3 place. Are there places where x is either positive 1 or negative 1? R is always 1 on this unit circle. Jake, what do you think? Right, and we have to give those as radian values though. So in terms of radians, where is this located?
0 and pi.
Right, 0 and pi. Those would be our two answers right there. Questions? All right, let's go ahead and do 21. Maya, what do you think we do first on 21? You're right. Dominic, what do you think we do now? Right? And you have to remember to put plus or minus in front of it. The square root of 1 is just 1. The square root of 2 we're just going to leave as the square root of 2. So now I look over at my list that I have over there. Is it okay to have y as 1 and the hypotenuse or the radius is radical 2? We have that, don't we? So I don't want to rationalize this. That would make it worse. Leave it the way it is. So I want to think of the quadrants where y could be positive 1 or negative 1. What quadrant's that going to be? All of them, right? Y is positive 1 here. R is radical 2. In this quadrant, y is positive 1, r is negative 2. In this quadrant, negative 1, radical 2, and negative 1, radical 2. So when that happens, see, usually we only have two answers when we have the triangle type problems. But if it's plus or minus, we're going to have to use every quadrant. Anybody know the reference angle there? Caroline, what's the reference angle? Good. So we know it's 45 degrees, which is pi over 4. Now with the pi over 4s, I know that they're going to cut this in half. So this is going to be just 1 pi over 4. If I'm starting here and going over to there, how many 45s is that? 3 of them. If I'm going around to this terminal side, or this radius, it's going to be 1, 2, 3, 4, 5 45s. And if I go all the way to here, there's 1 45, 2, 3, 4, 5, 6, 7 45s. And so that would be our answer. Now this is kind of tricky, so I don't want you to follow along, but I just want you to have seen this, how I can check it now. I'm going to check my mode. I'm going to make sure that I'm in radians. And I'm just going to check one of these answers. So to check this, I would have to do the sine of pi over 4. I'd have to get that answer. Then I'd have to square it. And then I'd have to multiply it by 2. And what I'm trying to get is 1, and I do get 1. So I know it's correct. Let me do it for 3 pi over 4 real quick. I plug in 3 pi over 4. I do the sine of 3 pi over 4. I get that answer. Then I would have to square it. So I do that answer squared. Oops. What happened? Oh, I didn't put over. Darn. Okay, sine of 3 pi divided by 4 is that. Okay, so then I have to square that answer. And then I have to multiply it by 2. And see how I'm getting 1? I'm plugging it back into the original to see if it works. Okay? So if you had time on your quiz, you could check everything. All right, number 2. I have to do the tangent here. What do I do in this kind of problem? Anybody remember? This is tangent times tangent minus tangent. So what I can do, guys, is factor out a tangent theta. Because this is tangent theta times tangent theta, and I took 1 out, I'm just going to have tangent theta left. What is tangent theta divided by tangent theta? So now we have to set tangent theta equal to 0, and we have to set tangent theta equal to 1. All right, so then looking at this, tangent is going to be y over x. Now this is a little bit tricky, and so is this. This is going to be saying, where is it that y is 0 and x is 1? What kind of a picture are we going to have? Is that going to be a triangle, or is that going to be on an axis? On an axis, which is called quadrantal. So I'm going to think of all these points. This point is 1, 0. This point 0, 1. This point's negative 1, 0. This point 0, negative 1. So where is y 0? Well, y is 0 right here, so 0 has to be a solution. But y is also 0 here. Should I use this point? Some people are saying no. Actually, we do want to use it though. Because what is 0 divided by negative 1? Is that still just 0 like it's supposed to be? Yeah. So this could actually be, if I have tangent theta equals 0, this 1 could be positive or negative. So that's why we could have an answer of 0 or pi. The same kind of thing holds true here. This is over top of 1. Y is 1, x is 1. Look at your special triangles over there. Which one has x1, y1? What kind of angle, guys? 45. So I would want to be in this first quadrant, x1, y1, radical 2. But think about it. If I have to get an answer of 1, what else could happen? Very good. I could have -1 over -1. So now we're talking about x being -1, y being -1. That puts us down in this quadrant. Plus, remember that all students take calculus concept. Right here, tangent's positive in this quadrant. So -1, -1. We just set a 45-degree reference. You guys try to come up with the names for those angles. Drew, you have them? Good. Questions on that? All right. Any ideas on 23, how we would start that? First of all, this x should not be an x. It should be a theta. That might confuse you a little bit. So think of a similar problem. What if this had been 2x squared plus 3x equals -1? Now, how would you solve a problem like that? Drew? Add 1 and then you factor, right? This is the same kind of problem. So we're going to do the same kind of thing. 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. So now I have to set up my double parentheses. Just like up here, to factor, once I had it like this, to factor this, I'd have to set up my double parentheses. Same thing here. 2 cosine times cosine gives me 2 cosine squared theta. Then I look here. What numbers multiply to be 1? 1 and 1. I check the outers. I get 2 cosine x. I check the inners. I get 1 cosine x. What do the signs need to be for me to get a positive 3 cosine x? Positive, positive. So now I have to set this equal to 0 and this equal to 0. And when I solve this, I'm going to get cosine theta equals -1/2. And here I'm going to get cosine theta equals -1. You should get 3 answers. See if you can find the 3 answers. Harish, what did you get?
I got 2 pi divided by 3, 3 pi divided by 4, and then 7 pi divided by 4.
Disagree with those last two. I do agree with the 2 pi over 3. But this would have to be radical 3 here as well. So this should be 60 degrees. And so this is going to be 180 plus 60, which is 240 for this second answer there. And 240 is going to be 60 times 4. So you should have had 4 pi over 3 there. And then this one should be one of those that's quadrantal because it's saying x is -1 and r is +1. So where is this located, guys? Right here is where x is -1. So what's this answer, Charlie? Pi. So those should have been the 3 that you came up with. Okay. All right, guys, down here I'm not going to do all these, but just to tell you, all you have to do is check all 3 of these. Notice the degree symbol. So all 3 of these you should be in degrees. These 3 do not have degree symbols, so therefore these 3 you'd have to make sure you're in radians. So you might remember how we can do the cosecant of something? Drew? Okay, so we have to do the sine, and then we can do x to the -1. Or you can do 1 divided by the sine of 10. Both of those would work. Let me show you what we're talking about here. So first of all, we check our mode, make sure we're in degrees. I can do the sine of 10, get that answer, and then push this x to the -1 key to flip it over, and there's the reciprocal. But I think it's even faster just to do 1 divided by sine of 10 from the beginning, and there you're finished because you're doing the reciprocal. Sydney? Those will not work for this. When you see sine -1, cosine -1 right here, that does not flip it. This actually finds an angle for you, which we're going to do after spring break. So you really don't want to use those right now. So what you have to do is, and that's why I usually don't tell you to do x to the -1, I just tell you to do 1 divided by it. Okay, so just be careful with that. Okay, questions there? All right, go to your notes packet now, and I'm just going to do the part that's new. Okay, so we're not going to do this stuff at the very end here. It's not necessary. We've already done all of this. Okay, I told you what this means. It just means to do the pi over 2 sine and then square it. This is the only thing that's a little bit different. Okay, so let's look at these. So these are without special angles. These are not 30, 60, 90s and 45, 45, 90s. It says if sine theta equals -8 over 17, find the secant of theta. And then this kind of got messed up a little bit. This should not be here. It should say theta lies in quadrant 1 or 4. Okay, so I'm going to draw a picture of this. It tells me that sine has to be negative. In which 2 quadrants is sine going to be negative? Mitchell, do you know where y would be negative? Because sine is y. Nope, 2 is positive because it's above. Where y would be negative, not x, y. 3 and 4. So I would want to draw my pictures in 3 or 4. But it says that theta must be in 1 or 4. So if we just said that in order for this to happen, we have to be in 3 or 4, and then they tell us theta is 1 or 4, which is it going to be in? 4. So we're going to draw our picture in quadrant 4. And what happens is they're telling us that for this theta, that the y value must be -8 and the r value must be 17. This is not one of our 30, 60, 90 or 45, 45, 90 ratios. But there is a way that I can find the secant. The secant is r over x. So I have to know what this x value is. How can I find it? Drew? It is. Look at all that stuff I wrote over there. Important stuff. What is it down there on the lower right? 15. Is it true that that would be a positive 15? Yep, because it's in the positive x direction. So therefore I would do 17 over 15. That's going to be the secant. All right. An angle theta passes through. Now, another way this could be written is an angle theta's terminal side. Terminal side just means the radius right here. So an angle theta passes through the point -3, -4. So I have to plot that point. X is -3, y is -4. So even though it says passes through, it really means that that's where it's ending. Yeah, Charlie? It's a triple over there, or you could have used the Pythagorean theorem. Do you see it down there, Pythagorean triple, 8, 15, 17, the very last thing in purple on the board? All right. So once I find this point, -3, 4, I have to go from this point to the origin and from this point to the x-axis. That's how we draw our triangle. The theta is always next to the origin, always, always. So what is this length here going to be? -3. And what's this going to be? -4. And what's true of the hypotenuse then? What's it going to be? Is it positive or negative? It's always positive, okay? So therefore now I want you guys to find sine theta, cosine theta, and tangent theta. Becky, what did you get for sine? All right. And Misha, what did you get for cosine? All right. And Michaela, what about tangent? Be careful with that. It would be -4 over -3. So just 4 over 3. Good. And also remember, in this quadrant, all students take calculus, so therefore in this quadrant, tangent should be positive. Okay? All right, one more I'm going to do with you. Flip over on the back. And let's do example 3 together. So I already showed you one's kind of like this. Anybody know what we should do? Looks very complicated, but what do we want to do always with these? Unless it's something squared with only 2 terms, we want to get a set equal to, Charlie? 0. So I'm going to bring this over to the other side. So we're going to have secant theta, cosecant theta. If I bring this over, it's plus secant theta equals 0. Do you know what to do now? You may know? What would you do if instead of it being secant, if it had been an 8? 8x plus 2 times 8. What would you do with that? Factor it out, wouldn't you? See, look, guys, if we have these 2 terms, we're looking, what is a common factor there? What can I factor out of each one of them? Secant. So I'm going to take out a secant. Natalia, what am I left with if I take out a secant? Cosecant plus, I already took the secant theta out, so I'm just left with 2. So that's what I get when I factor out the secant theta. I'm just left with cosecant theta plus 2 equals 0. So now I have to set secant theta equal to 0. And I have to set cosecant theta plus 2 equal to 0. So now look at this, secant. Baxter, what's secant the same as in terms of x, y, and r?
It would be r over y, or x.
Very good. There's always a 1 underneath every number. This is saying that the radius must be 0, and the x value has to be 1. Well, how could that happen? The radius has to be 0, but the x value has to be 1. Yeah?
It's quadrantal.
You would think it's quadrantal, but what did we say in the quadrantals that r must be? 1. So actually, this part right here, this has no solution to it. And Troy, I bet you were thinking of it the other way. Like if r had been 1 and x had been 0, then it would be quadrantal. But the way it is there, if r is ever 0, there's no solution to that. X could be 0, but not r. Okay, so now what about this part though? Cosecant theta, bring over the 2, equals negative 2. So what is cosecant the same as? Sydney, what's cosecant? It's a reciprocal of sine, so what's it going to be? Good. Now look at this, guys. Can r be negative though? Nope. So what's it going to have to be then? R has to be positive and y would have to be negative, right? So now we draw a picture. Which quadrants are we going to be in if y is negative, or if sine is negative? 3 and 4, either way, you want to look at that. And so y is negative 1, r is 2, okay? So what kind of triangle are we referring to here? 30, 60, 90. This is 30, and this is 30. We check and see, are we doing this in terms of radians or in terms of degrees? It's radians. So I have to think of what this angle would be in radians. Whatever my reference angle is in radians, that's going to be what I'm going to have as part of my answer. So 30 degrees is pi over 6. So it has to be pi over 6. This other answer has to have pi over 6 in it. Think of this in degrees now. This is 180 plus 30. It's 210 degrees. This is 30. 30 times what is 210? 7. This, starting here, going around here, I almost told you the answer, is 330. 30 times what is 330? 11 pi over 6. So those would be the two answers that we get. Okay? Questions? All right, so in class, right now, I want you to do the leftover examples here. That's all you have to do in class. I know it says to finish the worksheet, but we pretty much did that together. And then for homework, I will give you a worksheet once you show me these 3 that you know how to do them. Okay?